All right, guys, before we get started, are there questions on the homework? You're welcome. If there's no questions on the homework, the first main thing we're looking at is this right here. Log base b of b to the x is equal to x. It will be simplified to x. So when the base of the log and the number inside the log are the same, it's going to reduce to its exponent. So we can say log base 7 of 7 to the x. Well, since the 7 and 7 are the same, this reduces to x. I mean, we could say log base 8 of 8 to the third, and this would reduce to what? Log base 8 of 8 to the third would reduce to 3. Because when the base and the number inside the log are the same, they simplify, and we just have the exponent. The same thing is true for b to the log base b of x. Because what we're putting it to, and the base of the log are the same, it reduces to whatever's inside the logarithm. So 7 to the log base 7 of 3 would reduce to 3.
So what's the thing called when it's in the parentheses? What's the name for it?
That's what we're taking log of.
So that's like log base.
Yeah, log, so 7 to the log base 7 of 3. Now we could say 21 to the log base 21 of 4, and this would be 4. So if we look at this first one here, 10 to the log of 4, what is the, yeah, it would be 4. Because even though the base is not written for our log, this log, it is understood to be 10. Because our common logs, whenever we don't write the base for log, it's understood to be 10. Questions on this here? We go with this here so far. Let's look at the next one. Log base 5 of 25 to the x, yes? Well, it would be nice if we could rewrite 25 as 5 to a power, yes? Can we do that? What would it be? 5 to the second power, yes? Because this is nice because log base 5 of 5 squared would just be 2. But before we do that, because we have 5 squared, 5 to the second power, and that whole thing is to the x, yes? What did we say about powers of powers? They I'd cancel. Starts with an M. They multiply. We multiply them. So it's the same as log base 5 of 5 to the 2x. And what would that be? Because you had it somewhere. Because these match, yes? So what's left?
Oh, 2x.
2x. Log base 5 of 5 to the 2x would be 2x. Questions on this here? Questions on any of this so far? Ten to the log of 18 would be Now with our 10 to the log of 18, that's all numbers. So I could say 10 to the log 18, enter, and lo and behold, it is 18, because we don't have a variable. Now the next one, simplify log base 4 of 16 to the x. Well, the x kind of throws a hitch into us being able to just type it in. Because unfortunately for the calculators we have, we can't type x in as a variable. It has to be a number. But it would be nice if we could rewrite 16 as 4 to a power. Because if we do, the base of the log and the number inside are the same, and that would simplify. How can I rewrite 16 as 4 to a power? 4 squared. Which really is just telling me that I have log base 4 of 4 to the 2x, which is what? 2x. Yeah. Questions on this here? Are you ready for the next part? All right. Do some more simplifying. 8 to the log base 8 of x is what? Yeah, we can still do it. It's hard to see it like that, but really what it's saying is 8 to the log base 8 of x. Because this is following along with our b to the log base b of x is the number inside. Questions on number 13? Which part? What's the base with this here? So we're saying 10 to the log base 10 of 18 is, and we know that because if the base and what's the base of the logarithm are the same, it simplifies to just this here. So what's the base for number of the logarithm in 13? Because the base of our log is 8. What's the base we're putting the log to? Since they're the same, (27) to the log base 27 of 31 would be? Yeah. Let's look at 14. Log base 7 of 7 to the negative 3x. What would this reduce to? Yeah. Because here, when the base and what's inside it are the same, it reduces out and we have the exponent. Questions on 14? Questions on this here? Let's look at 15. Log base 2 of 64 to the x. Well, our base here is 2, yes? And the number inside the log is also 2, yes? No, it is. Now, if I could rewrite it as 2 to a power, then it would simplify, yes? 2 to the 8 is, let's try 2 to the 4th.
6.
So 2 to the 6 is our 64, so we could replace our 64 with 2 to the 6th. Powers and powers multiply, telling us that log base 2 of 2 to the 6x is what we had. And how will this reduce? To just 6x. Questions on 13, 14, or 15?
What in the world is 16? Oh,
E to the natural log of 20. E to the ln of 20. It would indeed be 20.
there you go, Rick.
Because what's our base for the natural log? E, yes? So we're saying E to the natural log base E of 20. Again, those two match up, so it is 20. One thing that I do find interesting, ln of E. What is the natural log of E? Mhm. Good. This would be. Because what's our unwritten base for the natural log? It is E. So the natural log base E of E, the base and what's inside are the same. So it becomes 1. The only other thing we're doing today is finding the inverse. Rewrite f of x as y. Because one of the things with our logarithmic functions is that logarithms and exponentials are inverses of each other. Now we saw this when we first started talking about exponentials and logarithmics. Because 10 to the, well, we did 10 to the x, let's do e to the x and the natural log of x graph. These are inverses of each other. The graphs of two inverse functions are going to mirror across the line y equals x, that purple line. And we can see here they do flip from one to the other. They're mirrors. So the natural log of x and e to the x are inverses. So we're going to be using those. Now for this here, our first step is to rewrite it as
Y equals
6x. Step 2. Switch x and y. So if we switched x and y, we would have x equals 6 to the y. Now we need to get y by itself. Now with logarithmics and exponentials, we need to get the term that has the variable exponent. So here's 6 to the y by itself. So if we need to add or subtract, we would. We don't normally deal with multiplication or division, but it's really addition, subtraction, get it by itself. Okay. So it is by itself, yes? Convert it to logarithmic. How would we rewrite x equals 6 to the y as a logarithm? So this is exactly what we did yesterday. Because we said what? Y, or I think it was x equals log base b of y if and only if what? B to the x is equal to, so how would I rewrite this? Base of
good job.
and that's its inverse. Now there is another way we could have done this to go from here to here. Because up to this point, the only way we've had, or way we could do this is if we apply, or just switched it using this here. Because we're starting off with b to the x is equal to y, yes? Now if I took log base b of b to the x, Well, what is log base b of b to the x? X, yes? That simplifies. What I do to one side, we have to do to the other, telling us that this is equal to log base b of. But in our general form, we said that b to the x equals y if and only if x is equal to log base b of y. So we could apply log and that base to it. So the one side simplifies to x, and the other becomes log base b. Okay? Well, let's say we start off with log base b of x equals y. Well, this is true if and only if b to the y is equal to x, yes? If I put log base b of x to the b, so b to the log base b of x. Well, what is b to the log base b of x? Well, I also have to put the other side to the b. So, this is another way we can do this. Now, how that works with this here, well, what we have at this point is x equals 6 to the y, yes? Well, to get that 6 to simplify, I would apply log base 6 of 6y, 6 to the y. We picked log base 6 because our base of what we're starting out with here is 6. Because our log base 6 of 6 to the y becomes y. But we also have to apply it to our x, which gives us log base 6 of x equals y. Questions on this here? We're ready to look at the next one. Y equals the natural log of x plus 3. So we need to rewrite f of x as y, yes? Well, there is no f of x.
So we do the opposite.
So
Y is x.
no, we can just move on to step 2, switch x and y. We only have to do step 1 if there is an f of x written. So switch x and y. X equals the natural log of x plus 3, or y plus 3, sorry. X equals the natural log of y plus 3. Okay, now we need to get y by itself. So this time, they gave us the equation in logarithmic form, yes? We want to rewrite it in exponential. So we're going the other way, yes? Now we can go through the process and doing this with logarithmic. Is this almost the same as exponential? We're saying x is equal to the natural log of y, if and only if what? What's our base again? For natural logs, the base was e to the x is equal to y, because our base with the natural log is never written. It's always understood to be e. So x equals the natural log of y plus 3. If we rewrote this in exponential form, what would we get? E to the x is equal to what? Y plus 3. Question on this here. Now what's the base for our natural log? E, yes? The other way we could have done this is if I apply e as a base to both sides, the e and ln would cancel, simplify out, yes? Leaving us with y plus 3. The other side would still be e to the x. And since y is by itself, we're finished, yes?
No.
It's not by itself. We need to. Telling us that y equals e to the x minus questions on this here. Now again, I said earlier that if it reflects across that line y equals x, they're inverses. So we can graph it here. So e to the x, luckily it's right in there, minus 3, and ln of x plus 3. Well, those do indeed reflect across the line y equals x. The only reason that the one in red doesn't drop lower than that is because the value inside the logarithm, inside this here, cannot be 0 or a negative number. We can't take the natural log of 0 or a negative. And before we move on, I can kind of explain that, because ln of 0, if we're trying to find this value, I mean, we could put e to both sides, really saying e to what power is 0. Well, the only way we can multiply anything together and get 0 is if one of the things we're multiplying is 0. Well, here e to the x, we're saying how many times are we going to multiply e by itself and get 0? Well, if x is a positive number, positive decimal, no matter what, it's not going to be 0. Well, we could say that x is negative. This might work. But if an exponent is negative, we move it from the top to the bottom. Well, the only way a fraction is equal to 0 is if the numerator is 0, and well, here it's stuck at 1, so that's not going to be 0. Only other option is if x is 0. Well, anything to the 0 power is 1. And it doesn't matter if it's e, the base is e or not. Doesn't matter what the number is. So these still hold true. So what's inside a logarithm cannot be 0 or negative. But questions on this here? We ready for the next one? F of x equals 11x. So we rewrite f of x as 11 to the x. Now we switch the x and y, telling us x is equal to 11 to the y. Questions on how we got through steps 1 and 2? Our next step is to get y by itself. So we can do that in one of two ways. One, we can just use our switching property to turn it from exponential to logarithmic. And if we do that, we get what? Log base 11 of x. And since y is by itself, we are done. The other way we could have done this is applying log base 11 to both sides, because our log base 11 of 11 to the y is just y. And it gives us log base 11 on the other side. Questions on A? We're ready for B. Y equals the natural log of x plus 6. Well, we don't have to rewrite f of x as y. So the first thing we can do is what? Switch the x and y. The natural log is already by itself, yes? So we need to rewrite it in exponential. Well, we can do that by doing our change method or just applying a base of e to both sides, yes? E to the x is, well, e to the x. E to the natural log of y plus 6 is what? Which part? So here, what's the base for the natural log? It's just e. It cancels out. So it is y plus 6. Now, let's look at a different one. So we'll come back to this. You don't have to write it down. What base would I apply to this log to get the log to simplify? Is it 7? Because 7 to the log base 7 of 9x plus 3 is So it simplifies out. So that's why we're picking the e. Now it doesn't simplify with our x, it just becomes e to the x. If we did the kind of switching method, x equals the natural log of y plus 6, it's just saying e to the x is y plus 6. We get to the same spot, but it's less of this is a, this is b, or this is, sorry, not a, this is b, this is our x, this is our y, and this is how it flips over. But to make this finalize, we would telling us y is equal to e to the x minus 6, and that's our inverse. Normally we would write f inverse of x, but here we can leave it as y. Questions on these here? How do we feel with these so far? Good? All right. I want to change the next one. Let's find the inverse of y equals 4 to the 3x minus 7. Now there is no f of x. So we can move on to step 2 and switch the x and y. Telling us x is equal to 3y minus 7. Now this one is a little different because now our exponential term, our 4 to the 3y, is not by itself. Well, what can we do to get it by itself? Yeah. Which makes the right-hand side 4 to the 3y. Okay. Move the equal sign over just a little bit. On the other side, we have x plus 7. Questions on this here? Now we would want to try to get it in exponential form. Or we can apply a log base to both sides. If we applied a log base, what log base would we use? It would be log base what? What number are we trying to get to simplify? The x7 or 4? So 4, because we're wanting to rewrite log base 4 to the 3y is just really 3y, yes? So if I take log base 4 of 4 to the 3y, this is 3y, because log base 4 of 4 will simplify, yes? What does it tell us the other side is? Well, it's log base 4 of x plus 7, because we took the log base 4 of both sides. The whole x plus 7, our whole 4 to the 3y. Is y by itself. So we would so y equals log base 4 of x plus 7 divided by, sorry. So is that problem a lot harder than the last one? No, there's more steps, yes, but once we got it there, we're finished. Questions on this here? Are you ready for the last one? Yes? Well, let's do a different one. Come on in, give me a number. 4. Okay, you can give me a different number. 22. Of y equals log base 22 of 3x minus 5. Well, luckily for us here, we don't have an f of x, so we don't have to switch it to y. But the first step is to switch x and y. So x is equal to log base 22 of 3x minus, or 3y minus 5. A little smaller eraser. 3y minus 5. With how we did the last one, what would be a guess on our first step? We'd add 5. We want to get the log by itself. Which tells us that x plus 5 is equal to log base 2 of 3y. What can we do next? We need to put it in exponential form, yes? Because log's by itself, so now we just need to switch over to exponential. So we can do that by our switching method, which we've done before, or we can put what base to both sides? 22. And the reason we picked 22 is because log base, or 22 to the log base 22 of 3y is, because this right-hand side becomes just 3y. The other side becomes 22 to the x plus 5. Because since we put that entire left side to the base of 22, it all goes into the exponent. Is y by itself. Divide by 3. So y equals 22. Questions on this here? So I would say the ones that were actually written in the notes would be what we would do for Algebra 2 in high school. These here would probably be college algebra. Yeah. Yeah. I mean, most of college algebra is exactly what we do in here, just a step or two further. Where our quadratics, our x squared plus 4x plus 4, most of those will give us more decimal. We have to use quadratic formula more. But that is it. 40 all and 43 through 49 odd. 45, 47, 49.